The ability of a fiber optic strand to transmit data is based on the optical phenomena of total internal reflection. Light waves have three primary properties that affect total internal reflection. These are reflection, refraction, and refractive index. Here we see a light wave as it propagates straight through two different mediums. The speed of the light wave changes depending on the medium through which it passes. Medium A and medium B each have a different refractive index, designated by a lowercase n. Medium B, with the slower moving light wave, has a higher refractive index than medium A. For example, water has a higher refractive index than air. A wave propagating through water will travel at a slower speed than the same wave in air. The boundary or interface between two mediums is where the refraction and reflection occur. Refraction is the bending of the light wave as it passes from one medium to the next. If the second medium prevents light from passing through the interface, reflection occurs. Two factors must be considered when determining the degree of refraction or reflection: the angle at which the light wave strikes the interface, and the refractive index of one medium in relation to the other. Snell's law is used to determine the amount of refraction that will occur between two mediums. Imagine a line perpendicular to the interface. This line is referred to as the normal. A light wave traveling straight into the new medium or along the normal will change speed but not change direction. However, when the light hits the interface at an angle, the change in light speed will cause the beam to change direction slightly and propagate through the second medium at a different angle. The angle at which the light hits the interface is referred to as the angle of incidence. The angle at which the light propagates through the new medium is called the angle of refraction. By placing the known values into Snell's formula, the degree of refraction can be determined. Snell's law states that if the refractive index of the second medium is greater than that of the first, the angle of refraction is smaller than the angle of incidence. Conversely, if the refractive index of the second medium is smaller than that of the first, the angle of refraction is greater than the angle of incidence. This is the principle that enables light to travel through a fiber optic strand. The core has a higher refractive index than the surrounding cladding. A light wave from the core will increase in speed when it enters the cladding, which has a lower refractive index. Notice that as the angle of incidence becomes greater, the angle of refraction approaches the boundary or interface. If the angle of incidence is such that the refracted light wave travels along the boundary between the core and the cladding, it is known as the critical angle. If the striking angle or angle of incidence is greater than the critical angle, the light will be reflected with no refraction. This is what is known as total internal reflection.